Hello everyone, this is a video showing our progress on final project. Our project is about implementing the transaction block part in Prism 1.0. Below is name of our teammates. Our goal is to improve the throughput of the Bitcoin client we have built before by introducing the transaction block into our client. In order to implement the transaction block, we made some modifications in the block structure. Here we split the difficulty into two fields, one for proposal block and one for transaction block. And in the content part, in addition to the transaction part, we add the transaction pointer part, which is a vector of hash pointers pointing to the transaction blocks. We also introduced some new structures. Transaction block pool is basically a hash map, stores all the transaction blocks that have been mined. We also reserved a transaction block ordered list, so we can get the order of all the transaction blocks in order to form the ledger. And we also add a field called referred transaction blocks in the state structure for every block, showing the transaction blocks that have been referred by this block and its ancestors. Here are some updates in algorithms. In miner process, when forming the block, besides putting transactions into the block, we also put all the hash pointers of the transaction blocks that have not been referred into the block. And if the block passes the transaction block challenge, we will broadcast this transaction block and put it into the transaction pool and ordered list. If it is a proposal block, after updating the ledger, we will mark all the transaction blocks it refers to as referred and update the state. In worker process, the updates are similar. When receiving a block, it will be checked whether it is a transaction block or a proposal block. If it is a transaction block, it will be put into the transaction pool and ordered list. If it is a proposal block, after updating the ledger, all the transaction blocks it refers to will be marked as referred.
We also conducted several experiments regarding to the throughput, the latency, and the security of our system. First, let's look into the throughput experiments. Similar to the midterm project, we are running our client in 3 processes, and we connect the first process with the second, and also connect the second process with the third. Our system will generate one transaction in every 0.4 seconds, and we run the simulation for 3 minutes, which means we will have 450 transactions in total. Also, we set the same mining difficulty for the baseline and for the proposal blocks in Prism, and we set a lower difficulty for transaction blocks. The result shows that the baseline only got 112 transactions in 3 minutes, while the Prism got 424 transactions in total, which are almost all the available transactions. We can see the throughput is largely improved by Prism, and we believe the improvement could be even greater if the transaction generation rate is larger. Then we conducted several experiments on latency. We used the same setting as above, and it turns out that the Prism has roughly the same confirmation latency as the baseline. This is because theoretically, adding transaction blocks will only affect the throughput, while it is the voting chain that really benefits the latency, so the latency remains the same. And finally, we conducted several attacks on our client to test its security. We first conducted spamming attack, which is that the adversary keeps sending invalid blocks or conflict transactions. It turns out that our client is able to defend this attack because we will sanitize blocks and transactions to check if they are valid or not before adding them to the main chain. We also conducted censorship attack, which is the adversary keeps sending empty but valid blocks. We found that the throughput will be compromised under the censorship attack because those empty blocks would be considered as valid blocks and will be added to the blockchain, but they have no contribution to throughput. Some of the hash power of the honest, or say their efforts, are wasted. But the security won't be compromised because the empty blocks are not harmful in the security perspective. Basically, this is what we have done by now, and thank you so much for your time.